All right, guys, so now we're back at it again here. So what we're going to be doing now is we're going to be simplifying radicals, okay? So the warm-up kind of got us prepared. Today we're going to have two parts here. We're going to talk about a concept, then we're going to try to use that concept to solve some problems, then we'll be doing some practice. So the idea is this right here. If you look at those examples that were on there, they said A times A. They did a few things like that. But the basic idea is anytime you have two square roots that are getting multiplied together, as long as this is a square root and that's a square root, I can multiply those. So you guys all know 7 times 7 will be 49, right? Well, if I punch it in my calculator, or if I remember, the square root of 49 is 7. Now, let's look at what happened here. This was the same number, wasn't it? 7 times 7 got 49. Square root of 49 is 7. See that right there? Let's do it again. Two square roots. If I multiply 11 and 11, I get 121. If I punch in square root of 121, it's 11. So if we see this pattern show up all the time, we can save ourselves some steps. Now, what I do want to point out real quick is, now, if these numbers are not the same, though, okay, now what happens is if I do 7 times 5, that is 35. But if I punch in square root of 35, that's a decimal, which means it is not exact. It's not in simplest radical form. So our answers will never have a decimal when we're doing square roots when we leave them in simplest radical form. They'll be simplest radical form or exact will be the two words you will see. So if we use this concept here with these basic problems, and we look right here, we could say, well, 3 times 3 is 9. What is the square root of 9? It's 3. And what we're trying to do is skip this step right here and just realize that anytime I have a pair of square roots multiplied, boom, it becomes that number. So therefore, if you're looking at this, that should be what? If you said 7, you're correct. Now, here's where people get confused. If you look up here, there are no addition signs. There are no subtraction signs. Technically, there's no division signs or multiplication, but anytime we write down square roots beside each other, it is multiplication. So in other words, if there's a multiplication symbol in between each of those, it's a given that that's multiplication. So if that was multiplication, what do you think these are doing? Are they adding? No, they are multiplying. And now you have 21. So this right here in simplest radical form would be 21. Now that did not have a square root at all, which could happen. Most of them will have a square root. If I use that same concept with this problem, I take that and we go straight to the answer. Hopefully you wrote down 2. But now these are not the same, are they? So therefore I have to leave them as a square root. What is 3 times 5? It is 15. Now remember, what's actually in between these two? Multiplication. How do I write that? I just write the 2 beside it, right out in front. That is technically saying 2 times the square root of 15. And this right here is simplest radical form. And now let's go to the last one. Now this one just throws in a little bit different scenario. We're looking for pairs. Now the key is pairs means 2. We do have 3 of these, but we can't pair up 3 of them. Anytime you have a group of 3, there's always an odd man out, it seems like. That happens here. So if you guys agree, these 2 are a pair, and these 2 are a pair. Those are the ones I can get rid of the square root symbol because I can simplify them. This will make a 3. It's going to go out front. This is going to make a 5. It's going to go out front. And remember, we are multiplying those together. Now we have these 3 here, not the same number, but remember we said you can multiply square roots together. 2 times 3 times 5 is 30. 3 times 5 is 15. Now I have my answer. So if you need to, you can pause this or go back, go through that again to make sure you understand that concept well. When you think you do, let the video run forward, and I'll go through how to do these. Now, if you notice, these are all just single numbers. They're not split up into their prime numbers. Okay, this is a prime factorization, which means I break it down as far as it can go. So what that would do is I would take 54. Doesn't matter what two numbers I start with, it has to be two numbers that multiply to give me 54. I'm going to do 2 and 27. 2 times 27 is 54. So what we've done is that is the same as this. We're just trying to get it in the smallest numbers we can. So now, can the 27 go down further? As you guys see, Coach Abernathy decided to join us. Coach Abernathy, would you like to say hi?
Hello, how's everybody doing today?
This is Unit 3, Coach Ab. We're going to be doing a little video this week, so now we're practicing. All right, now this 9 could still be broken down into 3 and 3, couldn't it? Now we have this looking like this one over here. Smallest numbers we can. And we're looking for what? If you said to yourself pairs, you are correct. If you said something else, go back and watch this first part again. Try to refresh that. Got a pair here. That becomes a 3. 2 times 3 is 6. Boom, got our answer. Okay, now with that in mind, what I'd like for you guys to do is pause this, work out those two without watching me, then let the video run, and now see if you get the same thing and watch me work it out. All right, so let's do that. You guys pause it, work it out. Boom, hopefully now you're back. So I'm taking the 150. Once again, you do not have to start out like I do. There's different answers. We will all end up in the same place. That's the nice thing about this. 2 times 75 is 150. 3 times 25 is 75. 5 times 5 is 25. We have a pair of 5s. These are not a pair. They will stay square root of 6. Always write the number that does not have the square root out front, the other part behind it. Now, on this last one, what I'd recommend is that 5's already out front, isn't it? So what we're basically knowing is when we break this down like we did here, there's already a 5 out here by itself. So this number is just going to keep coming down. The 84, though, we're going to split it up. 2 and 42. 2 times 42 is 84. We'll do 2 and 21. And then now, we'll take the 21 and make it 3 and 7. So this is where you would want to start working from. I take my 2 right here. That's a pair, isn't it? So now we have a 5. And remember, if you're thinking about putting a plus in there, don't do it. Okay? That's a bad call. We want a multiplication symbol. Boom. Got it. 3 times 7 is 21. 5 times 2 is 10. And guys, we have knocked this out of the park. So now you guys can go back through, watch that again if you need to. And what I'd like for you to do is start working on the practice. Okay? Now, the bottom two problems, they don't say practice, but basically what we have now is, if you remember, take that Pythagorean theorem problem, break down that number. Take the distance one, break that down. So what you guys should do is you're going to take that square root of 50 that we got on the first warm-up and break that down. You should end up with 5 square root of 2. Okay? You're getting that by taking a 2 and a 25, a 5 and a 5. Okay, pair of 5s, boom, goes there. And on your other one, the square root of 32, work it out. And if you need to, come back and watch me, but you should have this. We should have this. Now I'm going to kind of cheat, but remember our rule. If I got a pair of 4s, it becomes that. So work those out, make sure they make sense, then start on the practice, and we'll be rocking and rolling.